Hi students, in this lecture we are going to learn power, see how it is defined, right. Coming to power, it is defined as the rate at which work is done. So it is defined as the rate at which work is done. So P equal to dW by dt. It is defined as the rate at which work is done. And we are knowing that dW equal to F bar dot ds bar, right? dW equal to F bar dot ds bar. So this is also equal to F bar dot ds bar by dt. That becomes V bar. So it is defined as the rate at which work is done, which is equal to F bar dot V bar. So from this we can say power is a scalar quantity. So which is a positive if angle between these two vectors is acute, 0 if angle is 90, and negative if angle is obtuse. Okay. And here one more thing we have to focus. Whenever asking power, we have to mention by which force. Okay. We have to focus by which force. So power, or you can say instantaneous power, both are same. Next we define average power. This is notation for average. So average power equal to, it is defined as work done by time taken for that. Means it is work done per unit time. Okay. In the first, we are taking rate of change dW by dt. This is work done divided with the time taken for that. This is what we call average value. And coming to units, so you can see units. This is work by time. That means joule per second. Are writing this as watt, name of a scientist. So if you want to write symbol, it must be capital W. And if you want dimension formula will be C1's work done ml square t power minus 2, work done ml square t power minus 2 by time. So this is m l square t power minus 3. That is now dimension formula. So units are joule per second or it is watt, dimension formula. Sometimes we are using horsepower. 1 horsepower is equal to 746 watt. That is 1 horsepower. Okay. For example, we are taking a block on a surface, applying some force. See, see how many forces acting on the block. Applied force, gravitational force. If it is a rough surface, frictional force and normal reaction. If you observe, because of applied force, power delivered is a positive. Because due to this force, we can see block is moving right side. So between applied force and velocity vector, angle is 0. Therefore, by applied force, power delivered is positive. And if you see by frictional force, frictional force left side, but velocity is now right side. So power delivered by frictional force is negative. And if you see, because of gravity and normal reaction, velocity is along horizontal, but these two are along vertical, means the angle is 90. So no power is delivered by gravitational force and normal reaction. So like this, we have to specify by which force we want to calculate power. Okay. So to understand better, let us solve few problems based on power. Let's see the first question. A particle is moving along x-axis with a constant acceleration, two constant acceleration 4 meter per second square. If velocity is 0 at t equal to 0, then find the power delivered by net force. It is given net force at t equal to 3 seconds. And also find average power delivered by that net force in the time interval 0 to 3 seconds. So whenever we want to calculate average value, we have to mention time interval like average velocity, average speed, right? Displacement. So we have to mention the time interval. So moving along x-axis, acceleration 4, initially rest at t equal to 3 seconds, asked by net force. Okay. See how we solve the problem. So first write down given data. Acceleration is 4 meter per second square. Velocity is 0 at t equal to 0. We have to find power delivered by net force at t equal to 3 seconds. Also, we have to find average power delivered in the time interval 0 to 3 seconds, means first 3 seconds. So this is the given data, right? So if you want to calculate power definition part, focus definition part, it is F bar dot V bar, right? So power P equal to F bar dot V bar. So here mass is given 1 kg, right? So here asked question is power delivered by net force. So net force will be mass into acceleration, right? So 1 into 4. Between velocity vector and force vector angle is 0. Okay. So 1 into 4, 4 into velocity. See velocity how much? When t equal to 3 seconds. So velocity v equal to starting from rest. So a into t. A value given 4, t value 3 seconds, right? So velocity 12 meter per second. So force is 4 into this is 12 into cos 0. So 4 12, so 48. 48 watt. Okay. So like this, we can calculate instantaneous power or simply power, right? Okay. Next, we have to calculate what is average value. Okay. Average value means, see how it is defined. Average power is equal to work done by time interval, right? And we are knowing that net work is equal to delta K, right? From work energy theorem. Because we have to calculate now average power delivered by net force. So in first 3 seconds, you can see when t equal to 3 seconds, velocity 12. Okay. Therefore, work done is equal to delta K of m v square 12 square 144. This is now 72 joule, right? This is work done in first 3 seconds. So work done is now 72. Time interval given 3 seconds. So 72 by 3. Okay. See how many times 3 here. 2 times 12, 4. So 24 watt, right? So like this, we can calculate average power. Okay. Let us see one more question. See the question given. A uniform rope of mass 2 kg, length 2 meter is lying on the ground. One end of the rope is pulled up by a person with a constant velocity 1 meter per second. So length given 2, velocity 1. Average power delivered by the person in pulling the entire rope just off the ground such that the rope becomes vertical. So rope becomes vertical means, so time taken, length is 2, velocity 1 meter per second. So it takes now 2 seconds, right? For the rope to become vertical, it takes 2 seconds. 2 seconds and given constant velocity and mass is 2 kg. So average power delivered. See how we calculate that. So first write down given data. Mass given, that is 2 kg. Rope length is given 2 meter. Velocity given 1 meter per second and G value 10. So we have to calculate now what is average power delivered by the time rope becomes vertical, right? Then see how we calculate. So from definition part, average power. Average power is equal to work done by time interval. Okay. And if you see carefully, when rope becomes vertical, initially rope was on ground. If you consider ground as reference level, initially no gravitational potential energy and also no kinetic. Now we are moving that right upwards. That means now it gains kinetic energy as well as potential energy. So work done will be half m v square, v value given 1. That is a kinetic energy gained plus you can see center of mass of the rope will be midpoint of the rope, right? Center of mass. So we are taking gravitational potential energy raised. That is m g height equal to 1 because we are focusing center of mass of the rope since rope is uniform. If you remember in previous lecture we have discussed that to find potential energy we have to take integration. But if distribution of mass uniform, we can take directly the center of mass, that is midpoint. Okay. So this is now energy gained, kinetic energy half mv square. Gravitational potential energy mgh. Okay, this is work done. 2 gets cancelled. This is 1. This is 1 and that is now 10. 10 plus 1, 11. 11 joule. Right? So average power delivered by the person is equal to work done 11 joule, time taken, it is 2 seconds, right? Because length is 2, velocity 1 meter per second. So this is now 5.5 watt. Okay. Like this, we can calculate. See next one. Let's say the question given. A particle of mass 1 kg is moving in a circular path with a constant tangential acceleration 2 meter per second square, starting from rest at t equal to 0. So t equal to 0, velocity is 0. Find the power delivered by centripetal force, tangential force, and net force at t equal to 5 seconds. Okay. Mass 1 kg, tangential acceleration 2 meter per second square at t equal to 5 seconds. Right. See how we solve the problem. First, write down the given data. Mass given 1 kg. Tangential acceleration is 2 meter per second square. Velocity is 0 at t equal to 0. Right? Velocity is 0 when t equal to 0. Next, he's asking when t equal to 5 seconds. Right? Power delivered by tangential force, centripetal force, and net force. So following a circular path, that is now center. Now you can see centripetal force towards the center, take it as suffix C. Tangential force along a tangent. Now in this case, between tangential force and velocity vector, angle is 0 because starts from rest. So velocity vector and tangential force both are in the same direction. Right, when t equal to 5 seconds. So speed equal to, since at value constant, we can write directly at into t. So using the relation v equal to u plus at. Okay, u value 0. This is now 2. 5 seconds. So t value 5. 2 5 10. So 10 meter per second. That is speed at t equal to 5 seconds. Okay. Now we have to focus centripetal force. Okay. So power delivered by centripetal force. First calculate centripetal force. Centripetal force equal to mass into centripetal acceleration. It is a v square by r. I think here r is not mentioned, right? Okay. Let us take r value 1. Okay. R is 1 meter. Then centripetal force, mass into centripetal acceleration is v square by r. V square 10 square. R value is 1. So m into v square by r. So this is equal to 100. Okay. Next, tangential force. Tangential force equal to mass into tangential acceleration, and that is given as 2. So 1 into 2 is now 2 Newton. So now calculate power delivered by centripetal force. F bar dot V bar. See carefully here. Between centripetal force and velocity vector, angle is always 90. So no power is delivered by centripetal force. It is 0. Next, by tangential force. F bar dot V bar. So between tangential force and velocity vector, angle is 0, right, in this problem. And that tangential force, how much we got? It is 2, right? M into 80, that is 2. Velocity, how much we got? It is 10 when t equal to 5 seconds. So this is now power delivered by tangential force. Now he's asking power delivered by net force. net force. By centripetal force is 0, but tangential it is now 20. Therefore, net value is 20. Right? So here what we have to keep in mind, by centripetal force, no work is done. That's why there is no power delivered by centripetal force. Right? If you remember in the beginning, we have discussed by centripetal force, no work is done. When no work is done, there is no power delivered. Right? Right. See next one. See the question given. A particle of mass m is initially at rest. A constant force starts acting on it, and its velocity becomes v naught at time t naught. Find the instantaneous and average power delivered by that force in the first t seconds. Okay. Initially at rest, constant force. Velocity becomes v naught at time t naught. We have to find instantaneous power and average power. Right, see how we solve it. So first write down given data. Mass m given starts from rest. So v value 0 when t equal to 0. Next, velocity equal to v naught when time is t naught. Okay. And see one more thing, given force is a constant. Force is a constant. Force a constant means acceleration is also constant. In that case, so what we can do is modulus of acceleration equal to modulus of average acceleration. Both are same. And average value is given by change in velocity by time interval. Okay. So you have to keep in mind why we have taken like this. This is actually average value. Since acceleration is a constant, it is equal to the average value. Means both are same. Okay. So both are value wise same. Right. Now power delivered. Power equal to F bar dot V bar. Initially it was at rest, now it is moving. Therefore, between these two vectors, angle is 0. It is now by net force. Net force means mass into acceleration. So mass into acceleration is V naught by T naught. This is net force. Velocity. Velocity equal to, since acceleration is known, velocity equal to A into T. And A value V naught by T naught into T. Okay. So it is velocity how much? V naught by T naught into T. See carefully once. This is force, net force into velocity. And angle is now cos 0. Okay. So this value how much? M into V naught by T naught square of that into T. This is power delivered by net force at time T, which is nothing but instantaneous power. Next, coming to average value. Average value. So this is equal to work done by time. And in this case, we are calculating average power by net force. That means work done by net force equal to delta K, right? Delta K means it is a half mv square because initially it was at rest, right? That is equal to half m in the place of v. This is v, right? V naught by T naught whole square into T square and by T. So this becomes a half m V naught by T naught whole square into T. So this is the average power delivered in first T seconds. Okay. So like this, we can expect simple questions based on power and average power. Okay.